All right, it is finally week 7. We are down to our last set of homework assignments. So we're going to walk through how to use SALT for the week 7 assignments. So this one's going to be a little bit different because we have 2 different homework assignments for this. The first one deals with correlation and regression. So let's take a look at a problem like number 7 here, where we have some X data, we have some Y data, and it's asking us to make a scatter plot, determine the correlation, find the correlation coefficient, and things like that. So that can be challenging to do by hand. The scatter plot may not be too challenging. So we still want to go up here and we want to use SALT to try and make our lives easier. So it plugs everything in here for us. We've got all the data. And now we're dealing with regression. So we're going to come over here to the regression tab, and it's going to say pick an X variable, and they do a good job of labeling them X and Y. So that's pretty easy for us to get. And so now I have my scatter plot here, and I see kind of this increasing trend. So when I come over here, I say, oh yeah, it's definitely going to be this chart right here. That's definitely the answer, because that's exactly what my graph looks like. So then, as we come down, obviously I can play around with this. I'm just scrolling here. That was an accident. But as we come down here, it's going to give me some other information. So it's going to give me a regression line. We'll talk about that in a second, where it says, hey, y hat is equal to x times 5.1321 plus 61.9615. That's my regression equation. I can get those coefficients right here from this little part here. But with the question we had asked, said graph it, and then put the correlation coefficient in there, 0.9422. So as we go down, we see 0.9422, what they want right there. We can also compute the correlation coefficient using these things, but if we're going to be using SALT, there's not a lot of reason for us to try and do that. So then we get those things right there going forward. This correlation coefficient is strong and positive, and then we would take a look here and kind of answer the question about this. As X increases from 3 to 25, does the value of R imply that Y should tend to increase or decrease? That's just definition of a positive correlation, that as one goes up, so should the other. So then we see the next problem looks very similar. They're asking us to do the same types of things on the next couple of questions. So that's how you go about doing one of those. So let's see if we can find one that deals with correlation coefficient. Let's take a look at this one right here. We're just going to be able to see how we read an output when it comes to this, because we'll get to the next one where we'll see some of those things here. But when we take a look at an output that looks something like this, it's got all these things, we just need to know how to read it. So when I take a look at coefficient, that is the coefficient or the potential slope and intercept values that we take a look. Wherever the predictor says constant, that means that value right here represents the y-intercept in the equation. The value that goes with the variable weight, that one is the slope. So when I write my line, it would be y equals slope times x plus the y-intercept. So my equation would be 0.3935x plus 0.8435. And then we'd be able to answer the rest of the questions based on this. We get for each increase of 1 unit in weight, what does that change? That's always whatever the slope value is. Correlation coefficient, if we take a look here, that one's not given. So we'd have to understand the relationship between correlation coefficient and R squared. And they have a square root relationship on a linear model. So R squared is 97.8. We'll talk about that because that goes there. If I wanted to find my correlation coefficient, what we would do is we would take the square roots of 0.978, and that would give us 0.9889. So that's how we find that value. R squared tells us the percentage of the variation in y that can be explained by x. So the value for this is always the R squared value. And then obviously the balance, 100 minus, will be what is unexplained. All right, so let's take a look at the next one, where it actually walks us through this stuff in salt. So we're going to click on salt for this type of problem here. It wants us to use a scatter plot, find x bar, y bar, and then a regression equation, and then answer some of those questions with R squared, go on and so forth. So we're going to go back to regression. They do it well. They give us x, they give us y, and it creates our line. I can even click this button right here, and it'll plot the regression line for me when it comes to that. So now if I take a look up here, I say, okay, which one do I have? Well, I either have A or D. They look very similar, but the scales in X look very different. So I would come and say, oh yeah, this goes from 5 to 35. It's definitely going to be D, as this option right here, the fourth one. So now I want to try and find things like X bar, Y hat, and see what we got. So as we come down here, we'll take a look and see, does it potentially have any of these values in it? Well, I don't see X bar, I don't see Y bar, but I do see my equation here. I've got my slope and my intercept. This program calls it intercept instead of just constant. Slope, intercept, and then this actually right here gives me that model, even though it looks a little bit ugly. Y equals 4.5938x plus 31.796. So we're able to get those things pretty easily when it comes to those. This thing's also going to tell me my correlation coefficient and my R squared value. So that's going to help me. We're going to come back to these two. That shows me where I get my Y hat value right there. We can see, we take a look here, taking a plot, making sure it goes to the right point. We'll go back to that. R squared, which allows us to answer those types of things. And then it wants us to use this value in prediction. So one of the things about the least squared regression line, kind of what's coming up with this point right here, is it always goes through the point X bar, Y bar. It'll always go through that point on those values. So this one would be pretty easy for us to just figure out eventually. We know it would have to be one of these two values right here. And then we could just go back and take a look at the chart, kind of deduce that this has to be those numbers right there. So can we use salts with these right here to get those values? Well, let's come over here to the descriptive statistics. And if we take a look, we'll be able to see it's got both the X variable and the Y variable stats calculated out. So we would get 15.5 as the average for age in weeks. And then we would get 103 as the average for the Y variable. And as we see right here, we've got 15.5 and 103 as our values. So that's how we can use the SALT tool to help us figure out and do assignments for the first homework assignment that we have this week. So now let's take a look at the ANOVA aspect. This is the chapter 10 assignment that we have. So if we take a look at that and we go through, let's go down here. So number 7 has us running a hypothesis test using an ANOVA, and it wants us to find, oh my goodness gracious, all these little things right here. That is a ton of stuff, and then wow, I got to fill out this whole table. Yuck. Well, the good news is all we're going to do with this one is we are going to use salts, pop it up, and then we're going to let salt do all the work for us. So we come over here to inferential statistics. And in this case, we are running an ANOVA. So we're running an ANOVA, and we've got it right there. It breaks it up pretty easily. It's really hard for us to screw it up because it goes in general when it comes to those things. Then we generate our results. And it even tells us, here is your null hypothesis. All groups are equal. Not all group means are equal. So that can help us find out what our null and alternatives hypotheses are. When it comes to that, we specify alpha 5%, 0.05, and then we can use that as we go forward, right? So now the real thing is, where do I get all this stuff here? SS total, SS between, SS within, degrees of freedom, blah, blah, blah. Well, if we take a look right here on this table down at the bottom, it's going to give us just about all of those things. So treatments, errors, degrees of freedom when it comes to here, and then the bottom gives us that total of those things. When we start right here, the first one is going to be between, or the numerator. This one's going to be within, or the denominator, as we take a look at that. So I always remember it goes in alphabetical order, between, within. So we would get 2 and 18 for our degrees of freedom. And then we would come over here to the SS between. I get SS between right here, SS within right there, SS total right there. So we see SS between was 112, SS within was 592, and then the total should just be these two right here added together. That's where we get that total number. Then we'd have the mean squared between, MS between, MS within. They are all right there. MS between, MS within, pretty easy. We now are using the F distribution, and it gives us our F statistic. So we would come down here, we type in our F statistic, they call it the F ratio, comes from the table. And then it says, what are the numerator and denominator degrees of freedom? Those are the same as between and within. So between is the numerator, within is the denominator. Then it asks us to estimate the p-value. Well, p-value is given to me right here on this table. So the p-value is 0.2087. That's pretty large, so that's going to be greater than 0.1. And then we would fail to reject the null hypothesis when it comes to those problems. And then it basically just says, fill out this entire table. So it seems like a lot of pain work, but basically you're just taking this table and entering it right here, with the exception of adding in your do not reject conclusion when it comes to that. So then you'll do that a couple of times. Yeah, it's a little bit of a pain, but you will see a question where we give you an ANOVA output on your final exam, and you're asked to answer a question or two about it. So that's it for this one. So good luck. Hopefully these have been helpful over the term. And that's all.